Quick, graph y equals 5 halves times the sine of x by hand 2 different ways. This is part of the Family of Functions series. You will need paper and a straight edge, or you can download this PDF. Press pause as needed anytime during the video. Graph y equals 5 halves times the sine of x. The first way is with what we call the Sine Dance. We need to recall what the graph of the sine looks like, and there are 5 key points of interest. Put circles on those 5 points. These key points, in fact all points, are affected by the parameters in the equation, and in this one there is only one parameter, 5 halves times the sine of x, outside the function. So this 5 halves times multiplies each y value by 5 halves. Our initial point at the origin is vertically stretched by that factor of 5 halves, but 5 halves times 0 is 0, so it stays at the origin, 0, 0, and we'll plot it. At the end of the first period at 2 pi 0, again we multiply each y coordinate by 5 halves, vertically stretching it, but again that's going to be 0, so at 2 pi comma 0. Halfway between the initial and the end point is another point of inflection at pi 0. It is being vertically stretched by a factor of 5 halves, but again, pi comma 0. Halfway between these two first points is a maximum at pi comma 1. It's being vertically stretched by a factor of 5 halves, and it does change to pi over 2 comma 5 halves, or 2.5. And then halfway between these 2 points of inflection is a minimum at 3 pi over 2 negative 1, being vertically stretched by a factor of 5 halves down to 3 pi over 2 negative 2.5. Pause is needed. So let's go ahead and connect the points as a sine wave. We'll go with a frown or concave down, and then with a smile, concave up. This is one period of the sine wave. Let's go ahead and duplicate it, but in the negative direction to the left. So we'll start at the origin and go back a period, which is 2 pi, so negative 2 pi 0. Then that max goes back 2 pi as well. Another point of inflection moves back 2 pi to negative pi comma 0. And that point moves back to negative pi over 2 negative 5 halves. Connect the points as a sine wave again. Concave down, concave up. Let's compare it to the parent function. Our answer is in green, the parent function is in blue. And we can see that the blue coordinate times 5 halves is the green coordinate, not for just these points, but for every single point on the graph. Pause is needed. Some terminology or vocabulary. The amplitude of a wave is defined to be the maximum minus the minimum, all divided by 2. So for the sine wave, the amplitude is going to be, well, we have to figure out the maximum is at y equals 1. The minimum is at y equals negative 1. And substituting into this equation here, we get 1 minus a negative 1, all divided by 2, which is 2 divided by 2, or the amplitude is 1. Showing that on the graph, here's another way of looking at the amplitude. It's the distance from a max point to the line containing the points of inflection. It's also the distance from a minimum point to the line containing the points of inflection. Pause is needed. What is the amplitude for y equals 5 halves sine x? Pause to do this, resume when you're ready. Here again is our definition. Amplitude is max minus min, all divided by 2. So the maximum's at 5 halves, the minimum is at negative 5 halves. And subtracting those two, we get 5 halves plus positive 5 halves is 10 halves, and that's going to be 5 but divided by 2. So 5 halves is the amplitude, and we can see it graphically from the max to the line containing the points of inflection, which in this case is the x-axis, and from the min to the x-axis in this case. Pause is needed. Let's graph y equals 5 halves sine x a second way using a table. These are our normal values on the axes. Go ahead and complete the table. Pause is needed. These are the values you should just know on the axes. We need to create a second table. And our parameter, again, is multiply each of the y coordinates by 5 halves, and that's the only one. So the x coordinates are not affected, so the x coordinates will remain the same. So we'll start with 0 times 5 halves, and that is 0. So 0, 0 is on our graph. 1 times 5 halves is 5 halves. So over pi over 2 up 2.5. 0 times 5 halves again is 0, so pi 0. Negative 1 times 5 halves is negative 5 halves. So right 3 pi over 2 down down 5 halves to negative 5 halves. And 0 times 5 halves is 0, 2 pi comma 0. Connect the points as a sine wave, concave down, concave up. This is one period of the wave, so let's plot another one to the left. So we'll start at the origin and go back a period, 2 pi to negative 2 pi 0. The max goes back a period. This point of inflection goes back a period. And this minimum goes back a period of 2 pi. Again, connect the points. Frown, smile. And comparing that to the parent function as we did before. Now you try one. Graph y equals 1/2 times the sine of x. Use either method or both for the practice, and also answer the question, what is the amplitude? Pause is needed. Our answer is here in green. That's our 1/2 the sine of x, and the amplitude is 1/2 from the max to the line containing the points of inflection, or from the min to the line containing the points of inflection.